Okay, hello everyone. Let's get started. Please download Laboratory 12 on Blackboard and open with your Anaconda and Jupyter Lab. And if your Jupyter Lab doesn't work, you can use Jupyter. You can use the Jupyter Notebook instead. Okay. Please run the first script. It's today we're going to learn how to use NumPy package and use the some widely used functions in NumPy package. So first, please run the first script to identify your host name, username, and current information, and input your full name, a number, and the NumPy as a date. Okay. Sorry. Okay, let's continue. So NumPy is very, very important. I think it's the first big package you learn in this course, right? NumPy is a core library for scientific computing in Python. It provides a high-performance, multi-dimensional array object and tools for working with its arrays, right? So it's short for numeric Python or yeah, so that's why it's called NumPy, right? And then the basic component of NumPy is arrays. So a NumPy array is a grid of values. It's very similar to lists we learned, right? And all of the same type and indexed by a tuple of non-negative integers. Yeah, so actually we learned the list, but in list we can define different types of elements, right? But in arrays, most of them are in the same data type. And number of dimensions is the rank of the array, and the shape of the array is a tuple of integers giving the size of array along each dimension. Yeah, so in other words, an array contains information about the raw data, and you can use the function to do the operations, do the calculations on this array, on this data, right? Yeah, because if you want to use the list, it's okay, but you need to define several functions by yourself, right? But if you want to use the NumPy array, you don't need to define some other functions. Okay, so let's learn how to define arrays and how to do the basic calculations. The first one here is the 1D array, so it's similar to the list, right? Please import NumPy and rename it as NP, right? So it's just a habit. So because we think NumPy is so long, that's why we use NP to replace the NumPy package name. Okay, but if you don't like NP, you can also use NumPy. All right, and then please define a list called MyList from 2000 to 2009, right? Create a list of years, and then you can print it as a list, or you can define it as a NumPy array. So here's the first way to define a NumPy array. You can use NumPy.array, and then the argument should be the list name, right? And then right, and you see first one you print out my list. It shows like a square brackets and then all the elements of the list. And next one is about array. If you use array and print out, it's called array, and then a list inside of this array. Okay, it's about a 1D array, how to define it. And next one is about n-dimensional arrays. So it means n means it's greater than 1, right? So here is my other list is a 5 multiplied 2 array. It means 5 and it's like 5 rows and 2 columns array, right? That's why it's called n-dimensional array. So see how it looks like in a list. And in second one, the third line is used to define this array, right? Run again, so you see how it looks like a list, and next one is how it's about the array looks like. Okay, so it's a different way, right? Because each row in each line, right? When you print out this array, it's about how to define different dimensional arrays. Okay, so all right. So any questions so far? Okay, so next one is about array arithmetic. Once you created arrays, you can do basic NumPy operations. There's a variety of operations applicable on arrays. Yeah, so let's check some concrete examples here. 1D array arithmetic. So first one, we define 1D array with 0 to 96, okay? And after that, multiple all elements by 2. Let's see it one by one. First one, how to define a 1D array. First, you can use a list, right? You can define this list, or you can just use this list as the argument to define this array. For instance, here is a step 1, array 1 named NumPy. Please make sure to import NumPy as np.array, and then this list as argument, right? And after that, you can print out the first line would be the original array 1, right? So from 0, 12 to 96. And second one is multiply all elements by 2. So you can do it easily by just multiple, just a star and 2 means multiple all elements by 2. Okay, check out the result. The first one would be 0, and then the second element would be 24, and the last one would be 192. It means all elements have been multiplied by 2. And the last one to the power of 2, so it's double star. It means take all the elements to the power of 2. Check it again. So for 0, and second one, 12 multiplied 12 is 144, and last one, 96 multiplied 96, it's 9216, right? It's about how to, when you use this array name and do the calculation, it means you want to do the calculations for each element of this array. Okay, that's why you can print out itself, you can multiply by 2, you can get the elements to the power of 2. Okay, second one, the first one, step 4, is find the maximum values of this array and its position. Okay, here is another way to do the same thing. To get the power of 2, you can use the power and then set the power, NumPy to the power and array name, and 2 has no attribute array. Really? It's a little bit weird. Module NumPy has no attribute array. It's a little bit weird, I think, because array is defined in the NumPy package, and it's like a third-party package. So I don't know. Maybe you need to run from the first one again. So you say module name, you must have imported the module NumPy, but so any other guys have the similar questions, similar problems? So an error side module NumPy has no attribute array. Any other guys? I think it's so weird. Yeah, Jesse, maybe perhaps you need to like restart the kernel. I think maybe it will solve the questions. Yeah, it's weird. Yeah, please check. So for the first thing, it works for this one. If you define define this 1D array, there's no errors. There are no errors. So I think it should work for this example, because you only need to use the NumPy array to define it. Okay. All right. So does that work? Okay, I think I will continue. So if you still have questions, we can discuss after the class. All right. Okay, so here's another way to do the same thing. Use the function, the power function to get all the elements to the power of 2. And that's the second one. Here is the least, how to find the maximum value of the array and its position. So if you are using arrays, it's very easy. You don't need to define something. You can just use the functions for. Here is a max function, right? To find the maximum of value of the array, right? And then you see the maximum array, maximum element, it would be 96. Okay, and then positions of the maximum arg max of the array, right? And it's a position index number. Okay, it is 8, right? And one thing to notice is it's exactly the same as the list. So it means the index starts at 0, not 1. So the first one will be 0, 0, 1, 2, 3, 4, 5, 6, 7, 8. So it means 96 is the index would be 8. Okay, it is 8. And the next one is about to find the minimum value. Is minimum value. You don't need to write an algorithm or write a functions by yourself. You can just use a function from the NumPy array, min, right? Find the minimum value and then find the position argument, arg mean, right? Find the position of the minimum value. It's the step 4 and step 5. Okay. And next one is the define another array, 1D array with this number, right? So NumPy array. And next one is about the find the summation and the subtraction of these two arrays, right? So here, I only give you the example about how to find the summation of these two arrays. Please do it by yourself, how to find the subtraction. Okay, so first one, let's see how to do the summation. You can just use this plus, right? And how to do the subtraction. So you can use this way. Just use the minus. Okay, so you can write it. Please do it on your own computer, on your own cells. All right. Step 7, find the subtraction of these two arrays and run again. Yeah, this is would be the summation, right? You see, it's element wise. It means the first element will plus the first element. It will be the first element plus the first element of the second array is -12, and second one 12 and plus 0 is 12, and the last one 96 plus 84, it means 180. So it means the summation of the two arrays. Second one is subtraction. It's also element wise. So it is 0 minus -12. It means 12, and all the elements are all 12s, right? It's about step 7, and the last one, multiplication of these two arrays. So here is you can print array 1 multiply array 2. It is a step 9. Okay. Step 8. Sorry, step 8, not step 9. Right, I see that it's the result. It's also element wise. So it means the first element will multiply the first element of the 12 is 0, and second one 12, 0, 0. And the third one, 24 multiply 12, it is 288. So it is how to calculate the multiplication of these two arrays. So I think if you learn the matrix multiplication, you must have a question. So for now, it is the element-wise multiplication. So how to do the dot product, right? So if you consider this arrays as the 1D matrix, you must want to know how to do the dot product, right? And I will show you in the next example. Here is how to do the element-wise multiplication. You just use this star operation, star symbol, right? Okay, so any questions so far? Okay, it's about one dimensional array. Then this is a n-dimensional array arithmetic, right? Yeah, so first we need to define a 2 and 2 array. As you can write and show the example. Array is array 1 and it is array 2, right? 5, 10, 12, 15, and 20, right? And please make sure to have the correct format. Here it means 2 and 2. You need to use several square brackets, not only 2 brackets, okay? Because you want to define 2 and 2, right? And then find the summation and the subtraction of these two arrays. You can also use the summation and okay, subtraction. So here you need to do it by yourself. So again, so it is a second one, right? Subtraction. Then step 4, minimum number of in the multiplication of these two arrays. So it means step 4, perform a typical matrix multiplication or matrix product. Okay, so here is actually I think yeah, I think it's these multiplications of these two arrays. Yeah, mean value. I think it's not a multiplication of these two arrays. So because if you want to do the multiplication, you can first, if you want to find the minimum number or the positions of maximum number, you need to do the like matrix product. But I'm not sure why it's I think it's wrong, right? Because the step 4 multiplication of these two arrays, you just need to yeah, so you need to do the dot production. Yeah, so because now it's not a one dimensional arrays, so it means 2 and 2, right? So that's why here, if you mention the multiplication, it would be the dot product or matrix product, right? That's why here is there are two different ways to calculate this matrix multiplication because it's a two and two arrays. You can use this at operation symbol to do that, or you can use dot and dot function to do the matrix multiplication, and after that find the minimum number, right? So you can find after the print numpy dot minimum number of this multi-array. Try it. Yeah, so you can print them together first and then print the minimum number. The number, and then, right? So it's a minimum number. And next one is it's a step 4, right? Step 4 is find the minimum number and find the position of the maximum number in this one. So you can print the position. And use numpy.arg max and then calculate and the multi-array. It's a 3, right? 3 means 1, 2, 0, 1, 2, 3. So it means the last one would be the largest position. It will consider it, although it is a 2 and 2 array, so it will consider as a 1D array and give you the position. Okay. It's how it works. So if you want to know, if you want to give a matrix coordinates, you need to define it by yourself. You need to write a function by yourself. Yeah. So in NumPy array, you can only get the 1D array. So consider it's at the 1D array and give you the position of the maximum number or minimum number. All right. So it is a step 5. Step 5. Find it is step 4, right? Step 4. Step 4. And Mana is stored properly by. All right, so I think it's weird because actually you don't need to install NumPy manually by yourself. Actually, if you download Anaconda and Jupyter Lab, the NumPy has been installed in your Python environment. That's why we choose Anaconda, because it has installed some necessary libraries before. Yeah, when you install this software. So I think it's not supposed to be installed manually, but it's weird. But if you solved it, it's very good. Yeah. Yeah, thank you for letting me know. Okay, so let's continue. Next one is find the mean of the multiplication. So you can use the numpy.mean, right? It's you can use this way, and the mean of the first row. So actually you can use this way to get the first row. 0 to 0 means the first row. Let's check it off on the. Yeah. Okay, good. Yeah. 0 means the first row, and then only the column means all the numbers of the first row, right? So it means, and then call the numpy mean again. Let's write and see. The mean of this whole arrays would be 202, and for the first row it would be 127. Okay, so any questions for this example? Okay, next one is about the array comparison. So you can compare two NumPy array, whether they're equivalent by checking if every element at each corresponding index are the same. Okay, so for instance, if you have a 2-element array, so first one 1 and 2, and second one is 4 and 5. So if you want to check A is greater than B or not, so it will give you two falses, right? The first one would be false. It means the index 0, for the index of 0 of 2 arrays, the first one would be 1, and the second one would be 4. 1 is not greater than 4, so it is a false. For the index 1, 2 is not greater than 5, so it is also a false, and is smaller than be all true, right? So let's check out. The first one, define one the array, and the array first, and please make sure to import NumPy at first, and then define array and define another array, array 2, and compare. And if you compare to see if they are equal, so you can use numpy.equal function, right? Right. See, this is the first one, second one, and to check if they are equal, you will see a new array and all Boolean data types. And all elements at each corresponding index would be the same, right? 1, 2.5, 3.4, 7.0, 7.0. They're all true, right? And after that, define the third one. The third array is a different one, right? Check if the first array is greater than or equal to the third one. So you can use dot greater and underscore equal. So here's a little bit different, right? So you don't need to use the if statement and write by yourself. You can just use the functions in the NumPy. So use a NumPy here. If you want to check if they are equal or not, you can use numpy.equal. And if you want to check them if they are greater than or equal to, you can use dot greater than and underscore equal and array 1 and array 3. Okay, compare and see if these two arrays are equal. Right, so see the result. The first one would be false because 1 is not greater than or equal to 6. And the second one, 2.5 is greater than 1.4. So this is a greater than, and this is true. 7 is not greater than 7.5, false. Last one is equal to, right? It's true. That's about how to compare two arrays. Okay, so it's a last example, and the next one is about the cheat sheet. So actually, you can double click and find the website, the web URL of this cheat sheet figure. So actually, you can download it, and if you forget how to use some functions, you can check this sheet. Okay. Yeah, so it's very useful. You see, there are many functions, and I show you the examples of how to do that. Okay, and the last one is about the exercise. So it's about how to so in this exercise, suppose you have two one-dimensional arrays, array 1 and array 2, with the following values. The first one, 1, 2, 3, 4, 5, and 2 is 10, 20, 30, 40, and 50. Using NumPy, how can you create a new array 3, the result of multiplying array by array 2 element wise? So actually it's an example of this step 8, right? So if you know how to solve this step 8, you will know how to solve the problems of the exercise. Yeah, so in this exercise, please make sure to import NumPy first, and then define two arrays. And after that, you need to know how to multiply them together and print the result out. Okay, I think it's not very hard. If you don't know how to do that, you need to check this example. Okay, this example. Yeah, and I think you can solve it by yourself, right? Yeah, so that's today's class, and yeah, that's all I want to share today. If you don't have any other questions, please feel free to leave the meeting, and see you on Friday. Have a nice day, guys. And if you have some errors or questions about your gradings, you can stay here and have a discussion with me. Thank you, guys. What should the result would be? Actually, I forgot. I think you can calculate it by yourself. Like here, the first element of the result would be 10, right? The second one would be 40. Third one would be 90, 160, and last one would be 250. I think it is the result. Yeah. Okay, thank you. On line 3 of my exercise, tuple is not callable when trying to print out my array 1. Tuple object is not array, so I'm not very sure about that. What is? I'll stop recording, and then if you let me stop recording now.